Well, good evening, everyone, and welcome to 60 Minutes in Space. I'm Steve Lee, one of the space scientists here at the museum, and I'm going to make a prediction tonight. We'll see if I can actually do it or not. But for almost the first time, we're starting right on time. And that means we're actually going to end early. And I'm going under the theory that throwing away slides actually shortens a program. So we'll see if that's true or not. Anyway, how many of you are here for the first time? All right, well, welcome. And welcome to all the old timers too. But for those of you that haven't been here, 60 Minutes in Space is intended to be a little bit deeper dive into a handful of stories about space science from the previous month or so. And typically we have two of us here, but Kachun Yu is out of town tonight, so you're only going to hear about planets, which is what I do. And when Kachun comes back next month, he'll catch us up on the deep space stories, astronomy and astrophysics stories. So let's get started. All the regulars will be rolling their eyes because they know that I always do an update on the two Mars rovers. But this time it's going to be a little different because things have gotten very interesting on Mars since our last meeting. So I want to start just by talking for a minute about dust storms on Mars. This is a view of Mars from the Mars Global Surveyor back in the late 90s. It's orbiting Mars. This is the North Polar ice cap. And these fluffy things here are what are known as regional dust storms. And after having been orbiting Mars with spacecraft essentially continuously since 1997, we have a pretty good idea about the occurrence of these regional storms. And any given day on Mars, there's probably a dozen or more of these happening somewhere on the planet. And just to give you a scale for these little regional things, here's a map of the United States. I'm going to back up in a second, but here's that one dust storm that we looked at, and then this is the second one. So these are not trivial occurrences. There's actually a fair amount of dust raised off of the surface. And just to put this in context, when I'm talking about Martian dust, imagine something like smoke. The particles are very, very, very fine, and they can be lifted to extreme altitudes in the atmosphere, 40 or 50 kilometers above the surface. And when you get these tiny little particles that high, they can take a long time to settle out. And so we think that these smaller storms like this are what give the Martian sky its peachy color that we see from the landers. There's always some amount of dust being raised from the surface in these storms. And the other thing I wanted to say about these, I assume everybody has seen The Martian. And you know the beginning of that movie where there's a dust storm and it causes all sorts of mayhem. I love the movie. I hate the science of the dust storms. That is a very unrealistic view of Mars. The atmosphere on Mars is about 0.6%, as dense as it is on Earth. And the way this scales is, compared to Earth, you would need a factor of 100 higher, I'm sorry, I'm saying this wrong. If you had a given wind speed on Mars, the equivalent wind speed on the Earth in terms of the force that's exerted on particles or the surface is the square root of the Martian wind speed. So if you have say you have a 10-mile-an-hour wind on the Earth, you would need a 100-mile-an-hour wind on Mars to provide the same force. And that's probably about the maximum that you could expect. But a 10-mile-an-hour wind on the Earth is not going to be lifting antennas off of structures or blowing, rocks the size of softballs through the air. You're going to need much, much higher wind velocities. So think of this as more of a haze-raising occurrence rather than raising significant size particles. So this is the everyday view of Mars, and this is what happens every few to several Martian years. These are two images taken by Mars Global Surveyor in 2001. They were taken about a week apart. This is that. This is the same hemisphere of Mars. And in this time right here, there was a dust storm brewing in this huge crater called Hellas. And over the course of the next week, it escaped the crater and turned into what's called a planet encircling dust event, or a global dust storm. And so that happens every now and then. We used to think, based on telescopic observations from Earth, that this happened once every Mars year in the southern summer. And it turns out that was an observational effect because it takes 15 years from Earth to see all of the Martian seasons when the planet is closest to the Earth. So you could actually detect these things. And it just so happened that during the 1940s, 50s, and 60s, we were getting dust storms like this about once every 15 years. And so people thought, well, that means it's once a Martian year. And turns out that's just not so now that we've got spacecraft up close. So that's 2001. And this is a few weeks ago. So this is a global view of Mars from the Marcy camera, the Mars Color Imager on Mars Reconnaissance Orbiter. This is a flat map, sort of like a Mercator projection map of the Earth. That is where the Opportunity rover is sitting. The Curiosity rover is over here. This is a semi-global dust event at that point. It started in this area and has been sort of spreading to the east. But I want to show you sort of a series of images that cover the time here for about the last month. And so this is just a projection of a map like in the previous image. So this was May 28th, and I think right there is where Opportunity is. And so May 29th, the planet looks fairly normal. And then May 30th, we're starting to get a storm right there. And May 31st, you'll see that it's expanded quite a bit. So I want to do a series of these over the last month. So this was the beginning stages of this dust event. And by June 1st, it's quite a bit bigger. So let's skip a few days. You can see how much bigger the storm was. It just passed us there. And how sort of the general haziness of the planet. And between the 4th and 5th, it's really jumped in size. Okay, you get the idea there. I'm going to skip forward to by a couple of weeks. So now the planet is pretty socked in. And I think the last time step that I'm going to skip to is it ends yesterday. Oops, Sorry, I did it wrong. Well, anyway, you get the idea. It's very dusty on Mars right now. And this is a global view where they've sort of made a cartoon out of the outline of the dust storm. And here's where Opportunity is, there's where Curiosity is. So this was up through the 11th of June, and about 2/3 of the planet is covered by this dust cloud at that point. And the one thing to notice is the dust cloud in the area of Opportunity, it's got lots of structure in it. So there's actually, it's not just a haze of dust in that area, it's dust being lifted, and it's probably much thicker amount of dust in the atmosphere than what it is elsewhere. So the problem with an occurrence like this is Opportunity is a solar-powered spacecraft. And by having all this dust in the atmosphere, we're blocking the sun from reaching the surface. And this is a plot of what's called optical depth. It's a measure of, you look at the sun and see how much sunlight is actually coming through to the surface. Normally on Mars, the optical depth is about 1. And this is an exponential function for those of you that may remember your high school math. So an optical depth of 1, you get about 37% of the sunlight reaching the surface compared to if the atmosphere was completely clear, which would be an optical depth of 0. So this is a storm in 2007. That's the biggest dust storm we've seen since 2001. And so you see there, it got up to an optical depth of about 5. Here we're going in the current Mars year, and in the space of less than a week, we got up to an optical depth of 10.8, which is the highest optical depth that's ever been measured on Mars. And when you do the math, at 10.8, we're getting about 1,000th of 1% of the normal sunlight reaching the surface, which for all intents and purposes, it's pitch black on the surface. And this is a view of the power from the solar panels. Here was the blue line is the optical depth, and this was the sunlight, or the power coming out of the solar panels for the last 200 days or so, 150 days. And right here, there was a cleaning event where a dust devil went over Opportunity, cleaned off the solar panels. We were getting about, we were getting about 680 watt hours a day coming out of the solar panels. And then all of a sudden, by June 11th, we were down to 21 watt hours. And that is well below what the spacecraft needs to stay awake, if you will. And so on the 11th of June, the spacecraft entered what's called a power fault mode. And it doesn't have enough power to keep its systems running, and in particular to keep its heaters running. And so it puts itself to sleep, it turns off all the heaters, it turns off all of the instruments, it turns off the radio. All that remains alive or awake is a small part of the computer, which keeps, it's the clock in the computer. And so it keeps track of what time of day it is on Mars. And when it gets to be late morning, which is when the sunlight should be, the sun should be high in the sky, and potentially you could be charging your batteries. It wakes up the computer just long enough to see, are the batteries charging, or is there any current coming in from the sun? And if the answer is no, it shuts itself back off again, tries again the next day, and that's where we are. The spacecraft was last communicated with on June 11th. It has not been heard from since. But this is the way we expect this to happen. So it's in this power fault mode. The next deepest event would be when the battery gets low enough that it can't even keep the clock running, then the clock goes away. And so at that point, it's essentially inert, and it waits until the sun starts charging the batteries. And when it does, it periodically, every few hours, just transmits a beep that we should be able to hear from Earth. And when that happens, then they can communicate with the spacecraft, tell it to start bringing its computer back online and get the clock reset and everything. So that's the story right now. It could be a lot worse. The big danger about having the spacecraft in this deep sleep is when the heaters turn off, you have no control over the temperature of the internal temperature of the spacecraft. And if it's normally on Mars, we're cycling about 100 degrees centigrade per day, or roughly 200 degrees Fahrenheit from day to night. And that's a really hard thing for the electronics to withstand. But when you have this amount of dust in the atmosphere, that actually absorbs sunlight from the top of the atmosphere, and it keeps the atmosphere warmer than it would be otherwise. And so the last temperature they measured on the spacecraft, it was only minus 20 degrees Celsius instead of potentially minus 100. And so that's the good news. So right now we're just waiting. Every day at the times when the spacecraft might wake up to try talking to the Earth. The ground is listening. We've got antennas pointed at it. And every day during that time, they also send a transmission to the spacecraft that commands it to send a beep if you're awake. And so far, that hasn't happened. So stay tuned. That's, as I always say, when something exciting is happening, and this is sort of a hiccup, but I think there's a lot of reasons to be optimistic that'll come out of this. The duration of a dust storm of this magnitude, we can't really predict. There have been storms in the past where it might only last a few weeks. We're already approaching the 1 month point, and there have been dust storms in the past that last 2 or 3 months before they start to clear. So we'll just have to hang in there and see what happens. This is a computer simulation of what the sun looks like from Opportunity if it was looking in the sky. So this is the normal amount of dust in the atmosphere. And each one of these, it's going from like 1 to 2 to 4 to 6 to 8 to 10. And so you can see at 8, you barely have a glimmer of sun coming through. At 10, it's essentially dark. And this is the last image transmitted from the spacecraft on June 11th. And it's this is the horizon from where they are. And this is looking at the sky. The sun should be right in the middle of that image. And you can see that's not visible. So that's the story on Opportunity. So we'll update this next month. So let's move to the other side of the planet to say what's the dust storm doing to Curiosity. So today is day 2094, and Curiosity has the advantage. You see this device in the back. It's a radioisotope thermoelectric generator. It's got plutonium in it. The radioactive decay of the plutonium generates heat, and they use the heat to generate electricity. So it's not solar powered. It's happy as a clam to keep operating, even though the atmosphere is getting pretty soupy on that side of the planet as well. So just to remind you of where they are, this is Opportunity. Curiosity is over here. So it literally is almost the opposite side of the planet. And this was a view taken on June 15th, sort of a selfie. And normally we would see the far rim of the crater that Curiosity landed in. Right now, it's very hazy, and you really can barely see that there even is a crater rim. This is a view looking toward the rim of Gale Crater. So there it is. You see a little bit of detail. This was on June 7th, so the atmosphere was starting to get pretty hazy with the dust being lifted. And by the 3 days later, June 10th, when right before we lost communication with Opportunity, this is what it looked like. And I think this next slide is just an animation, 1 frame per day in between those, where you can see the haze thickening as time goes on. And this was a view taken in early June, where Curiosity had actually drilled into a rock. And this was the view, I think it was June 11th or 12th. And you see how much redder the surface is looking. And that's because the dust transmits reddish light through to the surface more effectively than any of the other colors. So it's getting very, very dark and very, very ruddy.